So this next example wants us to give the electron configuration for sodium. And notice that in parentheses here it does say to give the full ground state electron configuration for sodium. So again, this is just telling us that we want to follow the Aufbau diagram or the periodic table and build this up starting with 1s. So sodium has 11 electrons. And so now we can go to the periodic table or we can go to our Aufbau diagram. But either way, whether we're using the periodic table or the Aufbau diagram, it tells us that we want to start with 1s. And we know that 1s can hold 2 electrons. So now we move to the next, which is going to be the 2s. And that also holds 2 electrons. Then we move to the 2p. The 2p can hold a maximum of 6 electrons. That will bring our total to 10, which is okay because our element has 11, so we're not done yet. And so now after the 2p, we would move on to the 3s. Now the 3s can hold up to 2 electrons, but that would bring my total to 12. Sodium does not have 12 electrons, so we are just going to put 1 electron in the last energy level. And that takes us up to a total of 11. Now this represents, and I mentioned this I think a little bit in earlier videos, but I want to expand on it just a little bit here. This represents the ground state electron configuration for sodium. So what we find is that if I were to put a sodium atom into one of those gas discharge tubes, like those fluorescent light bulbs basically, and I were to turn on the switch, before the switch is turned on, this would be the configuration that those electrons would sit in, those 11 electrons. When I flip on the switch and I start adding energy, these electrons can jump up to higher levels. So this 3s electron might jump to the 4s or to the 5s. These 2p electrons might jump to the 3p or the 4p. I think, as I understand it, electrons tend to stay in their type of sublevel, but they can jump up to higher energy levels as they become excited. And so then once they become excited, they will start to fall back down to the lower levels, and as they fall back down, that's when they will release energy. But this represents the lowest energy that a sodium atom can have. This represents its ground state.